Howdy everybody, welcome to my sewing demo for the Gemma Sequin Starter Kit, which I have here packed as a Jewelbits science kit from Jewelbot. The big difference is that it comes with some cards here with some really basic ideas for your first circuits, and it comes with these felt pads. There's quite a few in there to choose from, and they're nice and colorful. The Jewelbit kits also come with the actual batteries for the battery pack, which the basic kit from Adafruit no longer comes with the batteries. One thing you're going to need, regardless of which way you buy it, is a good scissor. That's one thing that does not come in either kit, and you will absolutely need it. So let's take a quick peek at the essential tools here. Here is the Gemma board. It is a lovely little first starter board for enthusiasts. It has a micro USB port for loading programs, a JST power jack, and it has 6 pins, which do various interesting things. We'll get to that in another video. But the exciting thing is that it's this convenient little circular size that makes it great for sewing up some wearables. So for your very first circuit, you might want to just stick with one of the little sequin LEDs that it comes with and practice your sewing skills, which is what we're about to do. So the Adafruit version might come with a rather large pack of needles. The Jewelbits version came with 2. But that's enough. I only actually have used 1 so far. I haven't broken one yet. I do like to use one of the felt pads as a pin cushion and leave the other pins in the bag. That way we don't lose sharp objects. All right. Same with the conductive thread. Electricity will actually go through this to complete our circuits. If you can't find the end, one useful thing to do is to kind of prod at it with the needle. It's usually sticking up like right along the edge, and then you just pop it out with the edge of your needle. All right, back into my makeshift pin cushion here. Come on. There it goes. For this first very simple circuit, I only need about 10 inches, maybe a little bit more. So I'm using this white paper. I have a regular letter size paper here. I'm just going to use that to roughly cut my length. And then I'll stick this back in its bag right away so it doesn't unravel anywhere that I don't want it to. Okay, let's thread this needle. So you may find that you'll want to have like a full sewing kit handy. Because for one thing, a full hand sewing kit will come with a threader, and you don't have to figure out how to thread this needle without one. You can see, if I get this close enough and focused, there we go. The one end is quite frayed. So you could try recutting it and being able to send that through the eye of the needle. But honestly, I prefer to do it this way, where we fold it over nice and tight and shove that loop through the eye of the needle. These needles have nice big eyes, so that is super handy. So there it is. We'll just shove and pull and miss. So yeah, you can see how it would probably be a huge benefit to have a full sewing kit with a threader for your needle. So there we go. That's one end. Now, if you have done any sewing before, you've taken a sewing class, you might have been told to pull through and have this kind of loop going on and tie it here on this end. And we don't want to do that with conductive thread because we are more likely to cause short circuits accidentally with those 2 wires. So I'm going to straighten this back out, and I'm going to tie off the end with the needle by wrapping it around 2 fingers and tying it with that much of a loop. It doesn't take a lot, just a little bit of a loop. That way it's still easy to cut it back off of the needle, but you'll be able to have it stay on the needle. There. So that is my loop for how I threaded the end of that needle. And this part of it will not be part of my project. This part that is a loop, I will wind up cutting that off of my project. Then the other end, same thing. You can either loop it or you can just tie a really tight knot. This is the stopping knot. This is the one that's going to get caught up on the fabric, so the thread doesn't just pull straight through. So I'm just going to tie that with a couple of basic knots. Okay, so I am going to actually pull from the back of this. I have chosen a front and a back, and I want my knot to be on the back of my project so that the front looks cleaner. Then I'm going to thread this through, and I'm going to start with the ground. So see where it says G and D, that's the ground. My other thread that I'm going to do next is going to go on D1. But I'm going to start with the ground. That's usually a safe bet when you're working with electronics. Start with the ground. Okay, get this up here so you can see. Here we go. So there's my ground. I want to do this in a way that it will loop around that pin a couple of times, make it nice and secure, holding onto that pin. So look back here, and that comes through again. There we go. Nice and tight with that pin. And then I'm going to running stitch out to my LED. A running stitch is just in and out, in and out. Much like if you're running, you're going left and right, left and right. This is just in and out, and you don't have to be as fancy as I am, pushing the needle in and pulling it straight back out in one shot. You can do whatever you need to do to make that running stitch. All right, in and out, in and out. Nice and easy. So ground is going to connect to the negative terminal on my LED. An LED is a light emitting diode. Diodes have direction. So when I get one out of here, it's going to have a positive and a negative. There we are. So you can see on this side I've got the positive, on this side I've got the negative. Positive, negative. The negative side is the one we want to connect to ground on our project. So I'm sending this through, let's see, we'll go top down. And then kind of pick where I want that to go on here. Send it through. Whoops, I got caught on my board. Use my needle actually to carefully get that undone. There we go. All right. So, and just like I did looping on the board to get a nice secure connection, I'm going to try to get this through here one more time. So I'm going to go around the outside and then back through the little hole for the negative terminal. All right, there. That is one of the two connections we need in order to get this LED attached. So I've got my negative to ground. Next, I'm going to clip my thread and knot it so I can connect my positive to D1. You can connect to any of the numbered pins, D0, D1, or D2, in order to program your LED. There's also a constant 3-volt out, and V out should do maximum draw off your available power. So what you want to do for programmable ones are your numbered pins. So I need to actually secure this end. I'm going to come over one more place here and bring it back through again, but I'm going to leave a little loop on the back to turn it into a knot. So this is the tricky bit. There. And then I'm going to go under there and just do it a couple of times, making sure I have a really good knot on the back side of this project. There we go. Okay, so I can clip that. And clip it pretty close because I don't want to risk any of this line interfering with the one I'm going to put next to it for the positive. Okay, so I just clipped that and I need to retie a new knot. All right, I'm going to start exactly how I did before with coming through the back and this time coming up through the pin numbered D1. And I'm going to go down and back up again to make sure I have a nice loop on that connection. Ooh, get through there. There we go. Okay, good. All right. Now this is where it's tricky because most of this project is now attached and I want to make sure I'm going to land right here on the positive end of my LED with this running stitch. But I absolutely do not want it to cross with the other stitch. Okay, I think I managed it. No crossing, good. And I'll go straight down through that hole. My knot on the needle side is starting to fray a tiny bit, so it's getting tougher to push it through. That's okay. All right, last loop through that loop. There we go. That should be a really good knot. Okay, there we go. So notice there is a thread here that actually there's a thread here that's kind of touching. This one is too long. I'm going to clip it off. There we go. Now maybe this one also, just to be sure. Okay. I want to make sure none of that conductive thread scrap is around. I have a completed circuit. So it goes from the numbered pin out to positive, and then a separate line from the negative back to ground. That is my completed work. You'll notice there is no crossover of the two lines on the back. It should be a good circuit. So I'm going to now finish cleaning up. I'm going to clip the thread that was in my needle and put it away. Come on, get out of there. There it goes. Okay, needle back in the bag so I don't lose it and stab somebody by accident. I already stabbed myself by accident. We don't need any more casualties like that. And then all of this scrap conductive thread has to go away. It's going straight in the trash. I have a trash can under here. There. Okay, so that's it. I have already programmed this chip with a program that will flash the LED for 1 second and then turn it back off for a second. So I'm going to put in the battery pack. You can either connect it to your computer so it's actively on USB with power, or you can plug in the battery pack with the batteries in it. Note the batteries do need to be in it. Flip the switch, and there we go. So my light is now flashing with the basic blink program from Arduino. Getting that set up is its whole other thing, possibly in a separate video. So there we have it, our basic sewing of our first circuit with the Adafruit Gemma. So for this part of the video, I'm really just going to put up this slide from one of my slideshows for when I teach this in groups. It has the means of setting up Arduino IDE for doing all that programming that goes with this project. First, you have to actually download the Arduino IDE from arduino.cc. Then you have to fetch the definitions for the Adafruit microcontrollers. They are no longer supported out of the box by Arduino IDE. So those simple instructions that came with the Jewelbot, and even some of the stuff I've seen from Adafruit, doesn't necessarily have all the information in a really easy to digest format for setting this up, but there's really just 3 steps once you have it downloaded. Fetch the definitions using this reference to the JSON file, then install those definitions using the boards manager, and finally set up the actual settings in the tools menu to use those definitions. Okay, here is another one from my slideshow. I'm not going to show you every step of the way on this one. It'll be good for you to try it out just based on these instructions. So now that you have Arduino Ide set up, you shouldn't have to do the setup ever again. But now we can do a blink test with your basic circuit. So there is an example file that has it already made under File, Examples, Basics, Blink. Take a moment to read through and try to predict what happens in that program. You may need to change the LED built-in to just the pin number. Just replace it with number 1 if you were following exactly my circuit where it was connected to D1. Then you need to attach the micro USB between the computer where you're programming that and your actual Gemma board. Then it gets a little bit tricky with trying to load it. You will need to do a special double press. You'll know you've got it right when the dot star is on solid and the red light is gently flashing. This puts it in the bootloader for C++. If you are not quite pressing it right, you may go into the bootloader for CircuitPython, which I'm not going to cover. I'm going to stick with C++ for now because that's where all the basic instructions start with. However, Adafruit is moving almost everything into CircuitPython based on the resources I'm seeing. So once you have it into the bootloader mode for C++, you can press the upload button from Arduino IDE and load your program. It should start working right away. You may get errors in the Arduino IDE that will tell you a little bit about what might go wrong. Otherwise, it'll say something like verified successful, and the blinking light should work. Then you can start exploring what else you might be able to do with it, or other sample programs to give you ideas about things you might be able to accomplish in future projects. And that's where I'm going to leave the basic circuit and blinking light, and I'm going to start on a new project that's a little more complicated and interesting. For this portion of the video, I have sped up the visuals so you can see my sewing project while I talk at 2.5 times the playback. So you'll notice first that I actually planned out my project with a circuit diagram on the back of the felt. I just used a felt tip pen to draw the pluses and minuses of where the LEDs will be on the other side, and then drew where I'm going to thread those lines. You can see me struggling just a little bit with the thread. That happens with trying to get that like super fine dexterity going. You may find for yourself or your students that is something that maybe we need some help with. I mentioned earlier in the video potentially doing sewing kits so that you have better tools for doing things like threading your needles. That can be really helpful, especially in situations with those who might need assistance physically with their fine motor control. So here we go. I am now attaching the decorative pieces on the front along with the electronics on the back. This is just a clever little hack so that I don't have to do separate sewing with the decorations on the front. Now with the running stitch, I also have done something clever where I'm not actually pushing entirely through the felt. It is only pushing just enough through it to get the stitch, but on the front, it's not showing the thread. And then when I get to the end there, closer to the bottom, I can put more decoration on the front side. And again, I'm pushing through the blue, but not through the green at this point. So it will attach the green still without showing the thread on the front of the project. Here it comes with the first LED. Always double check, make absolutely sure you are on the correct end of the diode, whether it's plus or minus. I'm doing all of the minuses first out from the ground pin. That's usually a safe bet when working on electronics, to start with everything that connects to ground. And then here we go again, pushing through the blue but not through the green until I get to where the next LED goes. Then I push through and attach to the negative. Pretty much every stitch or two, I check to make sure the front is still looking good. Making sure I follow, especially around that bend, so that I know I will have enough space and not have any short circuiting by having the positives and negatives lines crossing. That's why I drew out that diagram in the first place, was to make sure that I wouldn't cause any accidental short circuits by winging it. There we go, that's number 4, we're almost there. So there's the 5th one, and then it's time to tie it off. So get it knotted and cut off at that point. So again, that's all of the negative terminals on the diodes, all threaded back to ground on the Gemma. Now if I was doing this again, I would probably measure out a lot more thread so that I wouldn't have to rethread my needle 3 times. I feel like that was a mistake I made in this project, because I could have just snipped off a longer length and then I would be able to just tie off the ends instead of having to rethread my needle for all 3 lines. Okay, I'm really cranking up now. We're at 4.5 times the playback, because this is really just the same as what you just saw. I'm just doing it again from a different pin. So the very first thing is, yep, there I am fighting with getting my needle threaded and all the things tied off. Again, this would be so much better if I had just done 1 string from the beginning. So I'm doing lots of checking front to back to make sure that everything looks fine on the front. Getting that secure connection on the next pin. And then running stitch all the way down for the next line of LEDs. There are 3 LEDs along that first line. And you'll see me pop through and check the front every time. Now this is going at 4.5 times playback. So this is actually pretty slow. It took me about 27 minutes to do just all this sewing on the project. So that should give you an idea about how long these take, so you can better plan your projects and the time, especially if you're a teacher in a classroom. You should know that it takes probably 20 minutes the first time you do that first circuit, and then a half an hour just for the sewing on a custom project. And there I go again with making a new thread and threading my needle again. I'm getting a little better at it by now, so that is probably the best threading job I've done in this entire video on both projects. And here it goes on the final pin to get those last 2 LEDs. And I'm doing this specifically so that I can have 2 different blinking patterns on those 2 sets of LEDs. The first 3 will be able to program one pattern, and those last 2 I'll be able to program a different pattern. There it goes with the last ones, so then it can get tied off after this last one here. And finally, that's the whole sewing project. As usual, make sure you get all of your stray threads out of the way. You don't want any of them hanging around for short-circuiting. Okay, I'm not quite ready to sew on the battery pack just yet. I want to be sure everything works before I commit to that part. I also have a little ribbon here that I'm picturing this being kind of a hanging decoration. So I would just pop holes in the corners here, and then I would have a nice ribbon hanger for it. But it's at least ready with all the circuitry to program my blinking twinkling garden and test it out. Okay, so let's do a little programming in Arduino. I already have Arduino open, and I am going to go under the File menu, Examples, Basics, Blink. This is where the documentation recommends you start for both the Adafruit Gemma docs and the Jewelbits docs. This is a built-in example with Arduino Ide. So it has a lot of extra stuff to help you understand what's going on. This is a huge comment here at the top about what it does. Some suggestions about like the onboard LED is usually pin 13, etc., etc. LED built in on the Gemma board is this little red light that's on board. There's also a dot star LED, which we do not necessarily get access to in this environment. Adafruit also supports Python, CircuitPython for programming the Gemma board, and they have a whole library for dealing with the dot star LED in CircuitPython. So we'll just do what we constructed here. So in my Ladybug garden, I have some of the lights on pin 0 and some of the lights on pin 1. So I'm just going to put those in here. I'm going to copy this line right here and do pin 0 and pin 1. Same thing here, I've got pin 1, and I also want to make copies and do pin 0. So this is some pretty easy modifications. The idea being that we had, I might just get rid of some of these comments. They're kind of in my way, but they're useful. Turning on the LED, waiting a second, turning off the LED and waiting another second. And then this is inside the main loop, so it'll repeat over and over again. That is a blinking light. Now, this means all of the lights will blink after 1 second. But if we add some more delays in here, we can get some interesting effects. Like if we do another delay here, that's only 100, that's a 1/10 of a second, that's 100 milliseconds. So this one's on pin 0, those will turn on 100 milliseconds before we turn on the ones on pin 1. Then wait a second and turn off the pins on 0. I might switch these actually and do the same 100 millisecond delay. So the ones on pin 1 are going to start 100 milliseconds after the ones on pin 0, and they'll turn off 100 milliseconds before the ones on pin 0. So they'll be on for a shorter amount of time. That seems like plenty to do for a quick test. I'm going to also just drop this out of here. I've done enough modifications. So here's the full program. The setup function runs when you first press or when you first load the program. And then the loop goes over and over and over again. So we will get some interesting blinky lights the whole way. Okay, so now I'm ready to connect my Gemma board. I've got the micro USB attached to the port on the Gemma board. I also have the other end I'm plugging into my computer right now. Nothing has happened. That tells me my switch is just turned off. There's a switch on the Gemma board. I'm just going to flip it, and now it's back on again. So I still have a previous program on the board where it just lights up. There we go. It just blinks the lights that are attached to pin 1. So that's working pretty well. That tells me my circuits are looking pretty good. Yay! So now I'm ready to load this program instead. To go into bootloader mode, there's a button on the board underneath the solid dot star, and I have to press it twice. It's not a tap tap, it's more like tap tap. Feel that pause of the beat in there, tap tap. So I'm going to go tap tap on that button. And notice the dot star is now green. The other onboard LED is flashing gently with the red. So that's ready to go to load in the Arduino IDE. There's a little arrow to the right that says upload, and I press that. And then I wait. Gemma is just a tiny bit slow with its bootloader, and that's okay. They have managed to make this bootloader supremely small. It is an extremely tiny bootloader, but that means it's just a tiny bit slow. It's not optimized for speed, but that's great. So I have some red text here, and that's okay. Don't be alarmed. It said smart device found, and it has some debugging info just in case things don't go well. And then it says, okay, erase flash. Now it's done. Done in 0.07 seconds. Verify. Successful. Bam. That's what we wanted. So now, if we look over here, it's blinking. I've got the 2 pins blinking at slightly different rates because of that programming I did where there was a 100 millisecond delay between the ons and the offs for each one. So these are some twinkling lights in the garden for my ladybug. Now, when I pull this USB, it's no longer going to have power to Gemma. So you'll notice once I pull it, it's off. It's not going anymore. That's okay. It just doesn't have power. So that's where the battery pack comes in. I'm going to briefly attach it here. Turn on the switch. And now we're back. So to finish this project, I can attach the battery pack back here. I'll just sew it on along with everything else, along with this button that I haven't sewed on yet. But I'll use regular thread. I won't use conductive thread for that. Similarly, to finish my project, I might add this little hanger with ribbon in the corners, just poke holes through and tie it off. That way I can hang this like a decoration anywhere I want. So there it is. My first project beyond the demo. My lovely ladybug in the garden.